Hi, this is AP Classroom Free Response Question, Unit 8, Set A. Alrighty, we're looking at motion, distance, velocity, acceleration. Lots of good stuff here. We do need a graphing calculator for this free response question. Okay, make sure you carefully read those directions before AP Test Day, because they will always be the same. Let's see, here's our situation here. And again, grab your graphing calculator, you will need it. Diego runs back and forth along a straight track. During the time interval between 0 and 30 seconds, Diego's velocity in feet per second is modeled by this velocity function. Okay, first part of this question is worth 3 points. What is the first time, t sub 1, that Diego changes direction? And then find Diego's average velocity over the time interval between 0 and that time, t sub 1. All right, let's look. Part A. Using the function, and I need my graphing calculator, using y1 equal to that velocity function which is given, we know that Diego changes direction when velocity changes sign. So I took that function for velocity, I plugged it into y1 on my graphing calculator. I had to adjust the window on my graphing calculator. X min I went from 0, X max I went to 30. I just tried y min of -5, y max of 5, and I got a function that looked like this. Went off the graph, but it didn't really matter. Crossed my axes, because I just want to see where that velocity changes sign. And the first time that velocity changes sign is right here. Remember that I want to calculate that 0. So using your graphing calculator, I want to calculate that 0. So this is good practice for finding zeros on a function. And when I calculate that 0, I find that this happens at a time of approximately 15.350 seconds. There's another, oh wait, what are points for this problem? I got 1 point for this. Now there's another portion of that problem. Find Diego's average velocity. Average velocity is finding the average value of a function, if you remember that. Average velocity implies finding the average value of a function. So the average velocity is going to be the integral between time of 0 and that time that we found, t sub 1, of the velocity function, v of t dt, over t sub 1 minus 0. It's like adding up all of those function values between 0 and t sub 1 and divide by how many there are. That's the average value. You do get a point on the AP exam for stating that average velocity, how you found it. Now this is my work. I'm going to plug into my graphing calculator the integral from 0 to 15.350. I can use that y1 that is stored in my calculator, all divided by 15.350 minus 0. And my result is approximately 10.504 feet per second on the interval from 0 to that t sub 1 that we found. The solutions were very specific on giving those time intervals, so I'm going to include those as well in all of my answers here. And I got a point for this. Okay, so there's the 3 points for part A. Each of the remaining portions of this problem are 2-point portions. And I'll show you where you can earn those 2 points. Read carefully part B. At a time of t equals 30, how far is Diego from his position at time t equals 0? How far is he from his initial position? When I hear that, I hear displacement. Or sometimes we say net distance traveled. Okay, so remember how we found displacement using integrals or net distance traveled. Now that accounts for all the forward and backward, forward and backward, forward and backward movement. So that is the integral on that time interval from 0 to 30 of v of t, which I have stored in my graphing calculator, dt. When I plug that into my graphing calculator, go to your math menu. Mine is option 9 for function integration. And again, using y1 that I have stored in my graphing calculator, I can enter that in there. And this is approximately 128.323. And you earned a point for stating that interval to give you that displacement. And you get a point for wrapping this up. So I'm going to state this in a sentence. And we earned a point for correctly stating that solution with units. Alrighty, let's go up and reread part C. Find the total distance that Diego runs during the 30 seconds from t equals 0 to t equals 30. Now remember, total distance traveled means that you include the forward running, backward running, forward running, backward running. So you include all of those forward and backwards. Okay, so that's a key. The total distance traveled is still represented with an integral, accumulated distance. But now on that interval from 0 to 30, I want to include both the positive and negative, so to speak, forward and backward distances. Again, I can use my graphing calculator to get your integral. That's your math menu, option 9. To get that absolute value notation, go to the math menu, arrow to the right to number, and absolute value is your first option. So you can put that right into your integral on your graphing calculator. That is approximately 243.425. So of your 2 points, you did get a point for correctly stating that integral for total distance. We need that absolute value. And then I'm going to pause and I'm going to state that in a sentence. Okay, and again, we get a point for stating our solution, and I'll just be very careful on units and time intervals on this problem. All right. Refresh your memory on part D, acceleration. Let's see. Let A of t represent Diego's acceleration during that time interval from 0 to 30. Using correct units, explain the meaning of that integral from 5 to 10 of A of t dt in the context of this problem, and then we'll find the value of that integral. Alrighty. Remember, acceleration is the rate of change of velocity. So I'm going to say, since acceleration is the rate of change of velocity, use complete sentences, don't let them guess to think about what you're thinking. Since acceleration is the rate of change of velocity, this integral is we're thinking accumulation of the antiderivative, which is velocity. So that integral represents is the net change, accumulation, in Diego's velocity, going backwards to the antiderivative, in, careful about units, velocity would be in feet per second on the interval from 5 to 10. And AP did need to see that time interval to earn that 1 point. So I've got units, I've got that given time interval from 5 to 10, and I referenced the going backwards to the velocity, accumulated velocity. Okay, after that, we can evaluate that thing, of course. So when I evaluate the integral from 5 to 10, this is the fundamental theorem of calculus. To evaluate an integral, I go backwards and use the antiderivative. Antiderivative of acceleration, of course, is velocity, upper limit of integration minus lower limit of integration. Just a side note, that's very easy to evaluate on your graphing calculator. On your home screen, drag that Y1, plug in 10, subtract off, I already have it in Y1, 5. Okay, so that's my little side note for you. That's easy on my graphing calculator, which is approximately 6.765 feet per second. This is a good one to practice your graphing calculator also for a lot of these computations. And I did get a point for this computation. All right, thanks for working through a really good problem. I covered a lot of topics today. Take care.